In this example, we have two different functions, this one here and this one here, and we have to decide whether they're odd, even, or neither. So let's discuss what even functions have in terms of their characteristics and what odd functions have. If a function is even, it's symmetrical about the y-axis, which means if you plug in the positive x value and then the opposite sign, that negative x value, you should get the exact same y value. So the heights are exactly the same. For odd functions, they're symmetrical about the origin. So if I plug in the positive x value and the opposite sign, the negative x value, you do not get the same y values. In fact, you get the opposite sign, right? Instead of positive 27, you get negative 27. So if I look at this original ordered pair, the signs flipped, right? So what our rule is saying is if I plug in the opposite sign of x, I get the opposite sign of y, right? So if I'm given two functions here and I have to determine whether they're even or odd, here's what you need to do. You have to find f of negative x. In other words, plug in negative x. If you plug in negative x and you get the original function, so if I plug in negative x and my answer is the exact same function, then this function is even. And the reason is, if you plug in negative x, you get the exact same original function, right? Now looking at odd functions, if I plug in negative x, right, and it says I get the opposite signs, so what does that mean? If I plug in negative x and both of these term signs flip to the opposite, that would be an odd function. How come? Remember, when you plug in negative x, you should get the opposite, right? The opposite sign here. So all of the terms should flip in terms of their signs. So let's check these out. So if I plug in negative x into the very first function, that just means wherever there's an x, replace it with negative x. I would have 2 times negative x squared plus 3. Order of operations, I have to square first, right? Exponents. So negative x times negative x, in fact, I'll expand this out. Negative x times negative x is positive x squared. So this becomes 2x squared plus 3. So what happened when I plugged in negative x? I got the original function. If you get the original function, your answer is even, okay? Looking at number 2, plug in negative x and see what happens. So if I plug in negative x, I would have negative x to the 5th plus 5 times negative x to the 3rd. So how do I expand negative x to the 5th? Well, exponents, you have to write your base 5 times. And then I would have plus 5 times negative x times negative x times negative x. You don't have to expand. I just want to show you where the signs come from. So if I multiply 5 negatives, my answers would still be negative, right? And since I have 5 x's, this would be x to the 5th. And then if I multiply 3 negatives for the second part, 3 negatives make a negative, right? So that's negative x to the 3rd times 5 is negative 5x to the 3rd. So taking a look, this is definitely not the original function, but I see opposite signs. Instead of positive x to the 5th, I see negative x to the 5th. Instead of positive 5x to the 3rd, I see negative 5x to the 3rd. So if the signs are the opposite for all terms in the original, your function is odd.